In exercise 503, we'll be moving more into the algebra of our data. So we saw in the previous exercises that data can be collected and graphed, and a relationship is observed within the data. In this course, the only relationship that you will have to recognize is a linear relationship. And obviously, linear means straight line. The reason that we only look at linear relationships is because you will then also be required to get the equation of that straight line. Now, we've done a lot of work in algebra on the equations of straight lines. We know that all equations of straight lines are in the format y equals mx plus c. So what we're going to do is we're going to take our data, as you can see in this example, sales of ice creams against the temperature. We can see that something is happening here. We can see there's a positive relationship. It's fairly strong. And in addition to that, in addition to being able to describe the relationship, we are now going to work on getting the equation of an appropriate line of best fit. Now, you can see that along the horizontal axis is the temperature. Often we graph, almost always we put x on our horizontal axis, and that is the independent variable. X is the independent variable. So in this example, the temperature is the independent variable. It's on the horizontal axis. And temperature will take the place of x in y equals mx plus b. On the other hand, on our vertical axis is sales, and it's referred to as the dependent variable. And then in the equation, the sales, S dollars, takes the place of y. So when drawing the line of best fit, we'll follow the instruction as it's written here. Try to have the line as close as possible to all the points. And ideally, you want your line going through at least 2 points that you know the values for. Another thing to check is make sure there are as many points above your line as below. We then, once we get our line, we're going to be talking about the slope of the line. And remember, we're closely tying back to our algebra study of straight lines. And we'll talk about the intercept, which is on the vertical axis, and we'll be able to study those two things, the gradient or the slope and the y-intercept, and come up with the equation. We've already been through this, that on the vertical axis, that's normally y, and in the place of y in our equation, we'll have S dollars for sales. Our temperature is our independent variable. It's replacing x in the equation, y equals mx plus c. Now, so you can see I've drawn the line of best fit and I've made it go through at least 2 points and done a rough check that there's 4 points above and there's 1, 2, 3, 4, 5 points below. So that's close enough. So we'd be very happy with that line of best fit. Now what we have to do is get the equation of that line. So a line of best fit has a slope of, and that comes from these red lines, the rise over the run between 2 points on the line. So we could have used the 2 points that the line actually went through, but they are not going to be very easy values to read off. I'll be trying to read off 300 and something. Is it 310? Should it be 320? So we move away from these points now and actually use, for example, this point up here, which we can clearly see is the point 24,600, and this point down here, which is 10,100. So the gradient for the line is 500 because we've done rise, and the difference is from 600 to 100. 600 take away 100 is your 500. And 24 subtract 10 is 14. So this is our gradient, this 35.7. And what it's measuring is the sales were $35.70 per increase in degree in temperature. The second part of the equation that we need to find is the vertical intercept, that is where the line cuts the y-axis or the vertical axis, and we read that at t is 0. Now, we don't actually have our axis at t is 0. It doesn't show. Don't fall for the mistake of thinking this 100 is your vertical axis. No, the vertical axis is over a lot further. We would go 10, this axis is, the units are 2, so we'd go 8, 6, 4, 2, and then eventually get to the axis. So it's very, very difficult to read off where this is going to, where the line's going to cut the axis. So rather than do that, we pick a point. So for example, 24 and 600 is on the line, and we're going to sub those values into our y equals mx plus c. Y being the sales value of 600, 35.7 being the gradient that we calculated from up here, 24 we get from the point we've chosen, and hopefully you will recognise that as a nice equation to solve. Now we're using our algebra skills to solve that equation. Whoops. So we do this multiplication, take it to the other side and subtract it, and get c is equal to 0.7. And so we've got the equation of our line of best fit as s is equal to 35.7t plus 0.70. Now let's have another example. Have a look at another example. The height and arm spans of 10 male swimmers are shown in the table. So we actually looked at this and said it had a correlation, very high correlation. We used our calculator to find that. You can see that from the graph that the points, there aren't too many that are away from our actual line of best fit. And that is again reinforcing the very high correlation number, the 0.98 I think it was, that we actually got for this set of data. So I've done A there, graph the data on the scatter plot and draw a line of best fit. Part B says find the equation of the line of best fit. Now, I think at this stage I will leave that, get you to work through it. If you need to go back and rewind this video to see the sorts of things that, the steps that I went through for the previous example, then please do that. Simply rewind, watch, listen to what I've said, and hopefully you can then apply it here in this example. And like I said, I will go through this one in class with you.